Climate change causes extreme weather events to become more frequent and more intense. This creates human health impacts, such as an increase in disease and food insecurity, and makes it harder to maintain the current standard of living while trying to cope with increased risk of natural disasters and higher food prices. Anthropogenic carbon emissions are one cause of climate change, so reducing these carbon emissions is critical for limiting future climate change impacts. Reducing the average household carbon footprint can have a significant impact toward mitigating future climate change impacts. A reduction of just 20% of the average household carbon footprint would reduce the overall national emissions of the United States by 7%. These reductions can come from making a variety of different types of choices, including how to get around, where to shop, what to eat, and your home energy use. The advent of lower-cost standalone virtual reality systems have made this technology more accessible to the general public. The difference between watching content on a flat screen or being visually immersed in the content through a VR headset can impact the learning experience. The question for this study is, how does that increased system immersion impact learning and behavior outcomes in a climate change risk mitigation context? Previous research has indicated that an increased system immersion can alter a learning experience by creating a more realistic and embodied feeling, and it has been shown to promote behavior change and self-efficacy improvement. Experiential learning, a prominent form of informal learning for adults, has been shown to be effective for improving self-efficacy as well. People may feel more comfortable making decisions when they've already experienced likely outcomes from making those decisions. And experiential learning can influence both behavior and decision-making going forward. Protection motivation theory explains adoption of risk mitigation behaviors. Essentially, protection motivation theory tells us that if someone perceives a threat to be severe and that they are vulnerable to it, and if they believe they know how to mitigate that threat, that the cost of mitigation won't be too high, and that they're capable of implementing those measures, then they will adopt risk mitigation behaviors. Self-efficacy is the common element that links all these frameworks to explain a potential pathway by which system immersion can be expected to influence learning and behavior outcomes related to climate change risk mitigation. The learning content used in the study is Meet Your Carbon Footprint, a 360-degree video published on YouTube by the United Nations Environment Program in 2020. The video uses place-based scenarios like a home and a public street in order to describe how a person's carbon footprint is impacted by choices on what to eat, where to shop, transportation, and energy use. Participants will be randomly assigned to a treatment group. They'll watch this interactive video on either a laptop using a mouse to explore the content or through a VR headset exploring in a more embodied way. The study follows a pre-test, post-test control group design. Participants will first consent to be in the study, then be randomly assigned to a treatment through a coin toss. They'll complete the pre-treatment survey, watch the video on the designated treatment platform, and then complete a post-treatment survey. The pre-treatment survey captures basic socio-demographic characteristics as well as the behavior outcomes, including intention to adopt behavior changes and threat and the coping appraisal from protection motivation theory. The post-treatment survey collects the same behavior outcomes in order to measure a change after the treatment, as well as the learning outcomes, including knowledge recall and the perception of learning effectiveness. The outcomes in the study use existing measures that have been published previously in the literature. Using common measures adheres to the precepts of open science initiatives that encourage research studies to be comparable with other research. This approach also follows guidance published by an iLRN working group dedicated to developing a framework that will allow the interdisciplinary field of immersive technologies to communicate and coordinate more effectively. The socioeconomic descriptors are captured to ensure the samples represent the same population using a chi-squared test. This will help control for these factors that are known to be associated with pro-environmental knowledge and behavior. The behavior outcomes measured both pre and post-treatment will be analyzed using a parity test, while the learning outcomes captured post-treatment will use an unpaired t-test. This study does have some limitations that may impact the results. Some factors relevant to the outcomes may not be captured during the data collection phase, so the results may reflect unknown influences. Substitute measures used for prior knowledge and actual behavior change may not accurately reflect reality. Political affiliation is used as a proxy for existing knowledge, so any identified learning gains may be related to differences in prior knowledge. Intention to change behavior has been shown to be reliable, though not as powerful measure for actual behavior change. The short treatment time will likely have only a small effect on the outcomes, exacerbating these other concerns. Data collection is ongoing. We have a target of 102 participants overall and will be completed this summer. The analysis will be completed by fall and results published this coming winter. Results from the study will contribute to our understanding of the impact of system immersion on learning and behavior in a climate change risk mitigation context. This knowledge will contribute to the development of evidence-based practice going forward. The study is designed to be easy to integrate into future research studies. The use of existing definitions and measures will help build a common knowledge research base to facilitate direct comparisons between research projects and better understand the impacts from immersive technologies.